All right. I don't know. It was telling me that live streaming wasn't available right now, and now it's going. Okay. So we're going to be solving these nonlinear inequalities with critical points. So let's say that one of the reasons that we have to solve an inequality or use of an inequality is when we have trying to find the domain of a square root function with a nonlinear function inside of it. So as the inside of that. So we know that the domain of a function is only the x values that create real outputs. Well, there are some x values, some inputs here that will create a negative under this radical. For instance, 0 would. 0 squared plus 4 times 0 minus 12. This would be the square root of negative 12. So f of negative 12, sorry, f of 0 would be equal to the square root of negative 12, which would be 2i root 3. And that's an imaginary number. So we know that 0 is not in the domain of this function. So the domain is only the inputs that produce real outputs. So how are we going to figure this out? We want to know when the output, what x values can we plug into x squared plus 4x minus 12 that will keep the output greater than or equal to 0. Because then we know those x values are the domain of the original function, because this inside has to stay greater than or equal to 0. Notice I don't have the square root on it right now. I don't care if the square root is greater than 0. In fact, the square root, if it can be calculated, is always going to be greater than 0. All right, so let's do this. Let's just kind of take a brute force approach to this, and let's just draw a number line. And that's a good way to get a set of all the x's, or to get a picture of all the x's, or at least the ones I've got labeled are the integers. We know that there's numbers in between here. I'm going to continue, just extend this out to 7, 8, 9, go a little further, 10. I'm all the way out to 10 now. Okay, so I'm going from negative 10 all the way out to 10. And let's just start trying some numbers. Or let's try all these numbers. And maybe we'll see we'll find something that happens here. So I'm going to try the number negative 10. So if I plug the negative 10 into here, I'm just trying it by brute force. Negative 10, so this would be 100, because negative 10 times negative 10 is 100, plus negative 40 minus 12. Is that greater than or equal to 0? So let's check. I'll put a question mark there. Let's see, 60 minus, yeah, it is. That's equal to 48. That's good. So over here, I know that negative 10 can be part of the domain. It's okay, because it's the square root of a positive number. So I know 10, an input of negative 10 is okay. So now I could try negative 9. So if I put negative 9 into here, I'm going to get 81, because negative 9 times negative 9 is 81. Minus or plus a negative 36 minus 12. Is that greater than or equal to 0? Let's see. This is negative 48. Yeah, that is. That's greater than or equal to 0 without even knowing exactly what that number is. So negative 9 gives me the square root of a positive number. So negative 9 can be in my domain. So I can keep trying and trying and trying and trying. In fact, I did that. You don't want to watch me plug all those numbers in. So I did that for us kind of ahead of time. And here's what I got. Okay, and I'm going to tilt this down a little bit so you can see all those inputs. So negative 10 gave me an output when I plugged it into the x squared plus 4x minus 12. Negative 10 gave me 48. Negative 9 gave me 33. Negative 8 gave me 20. Negative 7 gave me 9. Negative 6 gave me 0. Can I take the square root of 0? Yep, so negative 6 works. So far, everything here, I don't know why I switched over to red. I'll keep doing it. Square root. This is square root of 0 there. okay? And then square root of, negative 5 gave me, when I plugged it in, gave me a negative 7. So this is the square root of a negative. Negative 4 gave me a negative as well. It gave me negative 12. Negative 3 gave me a negative. I don't care that it's negative 15. I just can't take the square root of any negative. So if I plug in negative 3, what's happening is if I plug the negative 3 back into this equation here, I would have got negative, so the square root of negative 15. Well, square root of negative 15 is imaginary, so we know that we can't use negative 5 is not part of it, negative 4 is not part of it, negative 3 is not part of it. Let's see, negative 2 gave me a negative 16. You can't see that out of the corner, but it did. Okay, and then negative 1. 0 gave me a negative 12. We knew that from before. 1 gave me a negative 7. 2 gave me a 0 again. Oh, that's okay. Square root of 0, is that okay? Yep, square root of 0 is okay. So we're good there. So we can't use any of these that I X'd out, but we can use these other ones. Square root of 0. So let's try 3. 3 is positive. Put in a 3, get a positive value. This is good. Square root of positive. We're good. How about a 4? Square root of a positive. That's good. Okay, how about a 5? Okay, great. Square root of positive. All right, how about a 6? Okay, square root of positive. Okay, good. It's 7. Okay, good. All right, 8 is 84, so that's the square root of a positive. 9 makes the square root of a positive, and 10 makes the square root of a positive. Whoops, square root of a positive. So we were good. We were good. Then we were 0. Then we weren't good. No. Then we were 0. And then we were good. So it seems like these spots where we were the square root of 0 were kind of the boundaries from where we flipped from good to bad. Those spots where it's changing are called critical points. So we say x equals negative 6 and x equals 2 are critical points. Those are critical points. And why were they critical points? Well, they made us take the square root of 0. So instead of trying every other number, if I know that the critical points are where it's going to take the square root of 0, what I can do is I can just take whatever's inside of here and calculate when it's equal to 0. Solve it for 0. So let's do that. So I'm going to erase all these spots here. We know when it is. We did it by brute force, just by plugging in numbers. But I don't want to have to always plug in numbers. That's why we learned how to solve equations. Let's see. So I want to know what x's make x squared plus 4x minus 12 equal to 0. I want to know what x's make that equal to 0. Well, it's squared singular constant. So now we've got to go back to our algebra 2 days. As soon as we see squared singular constant equal to 0, we know we can use the quadratic formula or we can factor. So x and x, and then negative 12 is, let's see, that's either a 3 and a 4 or a 6 and a 2. So it's either 3 and 4 or 6 and 2 or 1 and 12. One of them gets to be negative, and I have to add them to get to 4. So that means one of them gets to be negative, and then add. So let's see. Negative 3 and 4, that's a 1. That's not 4. 3 and negative 4, that's a negative, but that's not going to work. How about 6 and 2? Negative 6 and 2 is negative 4, but 6 and negative 2 is 4. Good. So I need plus 6, negative 2. And then once I have a factored form, I can use the 0 product property. I can say, well, if this times this is equal to 0, then this, the x plus 6, has to equal 0. That would solve it, because that way, then it would be, I guess here, I could say 0. If I can plug an x in to make this x plus 6 equal to 0, I don't care what this side is. X minus 2 doesn't matter what it spits out, because it will equal 0. 0 times whatever is going to be 0. And consequently, x plus 6 times 0 would also be 0 in that situation. So then we don't care what the x plus 6 makes, as long as this makes a 0 over here, we're going to get 0 out. So if we go back to that, what x value would make this 0? Well, let's see. X plus 6 equals 0 when x is equal to -6. And x minus 2 equals 0 when x is equal to 2, just using my solving techniques. I just hit my critical points. I just found my critical points. Now, it's not always the case where between the two critical points, it's bad and it's good on the outside. It's just a critical point indicates a change. So we know the two spots where we take the square root of 0. So f of -6, back to my f of x equation, is the square root of 0, which is 0. And f of 2 is the square root of 0, which is 0. So I know that those are going to be the boundaries here. So what if I hadn't checked? What if I hadn't done all these checks? Well, if you noticed before, all of the numbers on the number line, kind of the only time they changed from being square root of positive to square root of negative was on either side of the critical point. So what I'll do now is, if I didn't know all of that stuff, go back into the alternate universe where I didn't want to plug all these in. I'm going to look at this and I'm going to say, oh, hey, I know where my critical values are. I plot them on a number line. Make sure you plot them correctly. And then you say, all right, well, let's see. Let's see if this section is good or not. So plug in a -8. So I'd come over here. I hadn't done this before. I'm going to plug in a -8. I'm going to check -8. So let's see. This is going to be 64 plus -32 minus 12. Is that greater than or equal to 0? Let's see. This is 32, right? Minus 12. 32 minus 12 is 20. Is 20 greater than or equal to 0? Yes, it is. Great. So that means that this is the square root of a positive, which means all of these will be square root of a positive because there's no more critical values. So one section of this section of the number line right here is part of the domain because all the numbers in this section make the square root of a positive. How about in the middle? Or make real. All right. Now in here we have, let's see, let's try 0. If 0's in the spot, try it because it's easy. 0 or 1, that's nice and easy. So plug in a 0. So we got to go back up and we got to check 0. Let's see, 0 squared, which is 0. 0 plus 4 times 0 is 0 minus 12. Is that greater than or equal to 0? Well, no. -12 greater than or equal to 0? No, not. So that tells me this is the square root of a negative because -12 is a negative number. So that means that all these representatives, every one of these in here, will also be square root of a negative. Because the only spot they change is at the critical values, and the only critical values that we found were the solutions to this equation, and those are the only two. So now we come over here and we say, all right, try a 5. All right, I don't know, could have tried a 4, could have tried a 3, could have tried an 8, could have tried whatever, it doesn't matter. Okay, you're going to try a 5. 25 plus 20 minus 12 is greater than or equal to 0. I know already this is 45 minus 12. I know that that's greater than 0. I don't care what it is. I just know that it's greater than 0. So this square, when I plug in a 5, I get the square root of a positive, something greater than 0. So then let's see. That means that all of these, because those critical points are the only spot where they change between square roots of negatives and square roots of positives, I know that those are all there. Good. So now all I have to do is describe these parts of the number line. And I'm going to do that in interval notation. This number line, the left-hand boundary of this keeps going to the left without bound. So this is -infinity, okay? And it goes all the way up to 6, to -6, okay, to -6. And -6, is that okay to take the square root of 0? Yes, it is. So I include it. Now I come over here, this section over here starts at 2. So the left bound of it, it always goes left bound, right bound. Left bound of it is 2. Can I use 2? Yes, I can. And does it ever have a boundary to the other side? It doesn't. It just keeps going. So it looks like that. So my domain is negative infinity to negative 6 and 2 to infinity, like that. So that's my domain. Okay, so now let me run through one real quick because that was a 30-minute explanation teaching you why everything happened. Let's just do an example quick, and I'll show you how fast it really is. Okay, find the domain of f of x equals 2x minus the square root of 9 minus, let's do this, x squared negative 2x squared plus 8x minus 3, like this. Okay, so all right, so first of all, this part of it, the 2x, is there any number, any real input, because we're only going to input real numbers, is there any real input that would make this imaginary? No. There's always going to be some real number outputs. We don't have to worry about that. All we care about is what's underneath this radical. I know that I want negative 2x squared plus 8x minus 3 to be greater than or equal to, not 3, I want that to be 6. 6. So minus 6. 0. There we go. So I want that. Okay, so now I want to find my critical points. All right, so let's see. Because I got this number line thing, and I don't know, here's where 0 is. I've got to find my critical points because I want to find where they change. So to do that, I want to find out where I'm going to take the square root of 0. Remember, we don't want the square root in this part of the equation. I want to know when I'm taking the square root of 0, this is making the outputs. So let's see, I'm going to divide everything by negative 2. So I'm going to get x squared minus 4x plus 3 equals 0. And in that situation, I'm going to get, let's see, if I factor this, x, and I got to get 3, and let's see, it's going to be positive. I can do that with a -1 and a -3, because that would give me a +3, and they'd add to -4. So that's just the factoring stuff. Okay, so now if we go back over here and we say, okay, so then that means x equals 3 is one of the critical points, and x equals 1 is one of the critical points. So here's 1, square root of 0, and here's 3, square root of 0. So now let's check to see. We got to check our intervals, right? So these are the breaking points between square root of positive and square root of negative. So let's plug in a 0. -2 times 0 squared plus 8 times 0 minus 6. Is that greater than or equal to 0? That's my question. And this is going to be no. -6 is greater than or equal to 0? No, it's not. So that means that when I plug in a 0, I get the square root of a negative, right? I get a -6 under the square radical. So I don't want that section of the number line. Let's try a 2. We've got to try something in between here, in between my critical points. So -2 times 4 plus 8 times 2 minus 6 is greater than or equal to 0. Well, let's see. -8 plus 16 minus 6. Yeah, that's greater than or equal to 0. Check. So this 2 here will be square root of a positive. All right, so now let's try something on the other side. Let's go over here, extend that out. Let's try 4. Okay, so if I try 4, let's see. -2 times 16 plus 8 times 4 is 32. Minus 6, is that greater than or equal to 0? Let's see. This is -32 and +32. That's 0. So this is back to -6 again. No, it's not. This is the square root of a negative. So now I know that the only section of my number line that's in my domain is the section between 1 and 3. So my domain, I just have to describe that part of the number line now, is from 1 to 3. Hard bracket on both because square root of 0 is okay. So that's my only domain in this thing. So there you go. There is my ditty on the inequalities with critical points. Good luck on those domain problems.